Day. This is Mr. Max. I gave you a test recently on geometrical terms and angle properties, and what I have here is the corrections to that particular test. Now, this is question 1 where you will ask what is the shape of the polygon, and you realize that it has got 10 sides and it's a regular 10-sided polygon. And because it's a regular 10-sided polygon, counting the sides like this, it therefore is a decagon. Now, part B is asking you the interior angles of a decagon. You had to prove that this particular angle, let's suppose we say this angle here, or even this angle here, and this one here, all of them, that each of that interior angle is equal to 144 degrees. Well, you can use the formula which comes from 180. If you use that formula and you look through your book, you will see that this formula is there. And this is giving you the angle sum of each of these angles. If you add them up, they give you, obviously here you will put a 10, the number of the total for the sum of the interior angles. But you divide it then by n in order to find the interior angle. Now this is a longer way to go. There is, however, other methods and way how I can explain this. But what you need to remember is that there is another easy method, and that is if you take, for example, if I extend this particular line here, and suppose I use a different color, and I look at that particular exterior angle here, this angle plus this interior angle, they are on a straight angle, so they must add up to 180 degrees. So that means that an interior angle plus an exterior angle should equal to 180 degrees. And to find an exterior angle, we simply use the formula of 360 degrees and we divide it by the number of sides, because this is giving us a total. The 360 degrees means all the exterior angles. If you were supposed to extend those lines, all the exterior angles of any polygon will always add up to 360 degrees. So that's why I was using this particular fact. And then obviously, in order for you to find angle OFM, which is this particular angle here, well, that one is just easy. It's half of 144, which is 72 degrees. Now, for the particular question here, I said you must leave it out because there's some trigonometry that is at play. Now, we are going to do the trig ratios where we are going to talk about the sine of an angle. And the sine of an angle, like this particular angle here, it's always the distance that is opposite that particular angle, and the distance opposite the 72 degrees. And then we always divide by the longest side of a right angle triangle, which is called the hypotenuse. So we are going to do that, and that is why you have that this distance here is equal to the sine of 72 degrees is equal to opposite over 10. The opposite is what we're looking for, which is that when you cross multiply, obviously you end up with that. Remember, I always give you answer to 3 significant figures. So this one is a bit tricky, but later on when you come back the first week or so, we are going to start with trigonometry. And what I will do, as soon as I get the clarity from the government, I'll also send you the updated year planner, so you can know exactly which topics we're going to cover, which particular time. Now, there's another formula as well, that if you have a triangle, it doesn't really matter whether the triangle is it's a right angle triangle or not, and you have got two sides given, and you have got an included angle. The formula to use is to find the area of that triangle. We're simply going to use the formula half times, now you multiply the two sides, and then you're going to multiply this also by the sine of the particular angle that is there. So that is the formula that I used. Again, as I said, we are going to come back to this one, so don't worry too much about it before or only up to the later case. But in any case, I've managed to find the area of 1 And because if you look at your slide previously, you realize there are 20 of such small triangles. Multiplying it by 20 gives you about 294 square centimeters. That will be the area of the polygon. Now the area of a circle is very straightforward. This formula is pi times r squared, and you were told to use 3.14. Now when you multiply that by 10 squared, you get 314. That takes care of that. And then you have to find the area of the shaded part, and you just simply subtract in order to find the approximate answer that we were looking for. Question 2, again, I just gave you part of a polygon. Now the formula here of 360 divided by n, it's also true for the angles at the center. The angles at the center of any polygon, the angles here, they will add up to 360 degrees. So if you divide it by 18, like what I did here, you definitely will be able to tell how many sides the particular polygon will consist of. So this formula is quite useful for many things. And question 3, 90 degrees angles in a semicircle, 60 degrees angle sum of a triangle. That means if you add all the three angles of a triangle, you add up to 180 degrees. So one is missing to give you that particular 180, which is 60. 45 degrees here. That was an isosceles triangle. Question 4, this is also part of the work that I gave you today that I said you must write down. Vertically opposite angles, co-interior angles, corresponding angles. I hope that you can go through this so that you can see it's in the 300 and something, 362, 367, 370 in your book there. Question 5, if you had a look at it, you will also realize that if you add up all the three angles of the triangle, again, they should give you 180 degrees. Simply create that equation and then you solve the equation. And you also realize that you are dealing basically with an isosceles triangle because of that fact, if you look closely at the drawing. Now, as for this particular question, it is also important that you go through your book there in terms of the other polygons that you have. This is an irregular, not all the sides are equal, right? This side might be equal to that side. These two sides must be equal to each other, and maybe this one is equal to that one, but not all of them are equal. Not all of the angles are equal. Here you have got a reflex angle, yeah, and here you have got acute angles, and so on and so on. But the bottom line is that the angles, they all add up to 720. Again, go check again that stuff, and then you simply solve this equation in order to find what is the value of x. Now, had they ask you what is the reflex angle, the biggest angle, then you simply be taking that 3 and you multiply it by 72 in order for you to find that particular angle. So that's 210 plus 6, so it would be 216. Suppose one asks you that question for you to find that particular triangle, or that particular angle rather. Again, here you have got a regular, if you count, octagon, 8 sides, right? And the interior angles on an 8-sided polygon, they add up to 1080. Simply divide by 8 in order for you to get each one of them. You could also went the other way around. You can say, well, the outside ones, they will also be 8. Then you can say 360 divided by 8. And when you do so, you are actually calculating an exterior angle here. And when you find that exterior angle, you realize it's 45 degrees, and then you can actually find angle x, because angle x will simply be 180, because remember they add up to 180, the exterior plus, and then that should give you the required result. Now this one is a little bit interesting. Remember, first of all, that's 90 degrees, and then this one here is 30 degrees. Okay, so this one here can be 60 degrees, so many things. Then this one here can be 120. But what you realize also is that if you add to this angle here, which is 90 degrees, and you add this angle here, which is 30 degrees, you will still get the same answer. That is, an exterior angle of any triangle here is equal to the sum of the two opposite interior angles. That 90 degrees, for example, is equal to 60 plus 30. Here, very straightforward. Yeah, all these x's outside are representing exterior angles, and because they're exterior angles, they will always add up to 360. And you can find 4x by simply dividing 360 by 6. Question 8, very poorly answered. I hadn't managed to look through. Well, first of all, you realize that angle x and angle y are corresponding angles. So I'll let you go read up on them. And what we know is that corresponding angles are equal. And also what I realized is that by looking at these two lines here and here, these two primes, they tell you that these two angles must be equal. And then you can play around, you realize that you have got similar triangles, and therefore those two angles will also be equal. Now, with this one particularly difficult, you have to draw a line here. This is a chord, and if I label that chord AB, for example, I will realize that it creates this angle at the center. That angle is 88 degrees, and the same chord creates the angle here, which is what I have 44 degrees. So that 88, the angle at the center, is always twice the angle at the circumference. So that means that is 88, and this one has to be 44, as I showed you with the arrow. So now if you look at that little triangle there, so I have my 44 right there, I have my 50 right here. Then I can simply calculate this particular angle here, and to calculate that angle, I will then also be able to calculate angle x. So that is how I managed to realize that angle x is 94 degrees. This is angle in the same segment. What that means is if I draw a chord here, this is going to be this major segment, part of the circle. This is the minor segment. You see that these angles here, they are in the same segment, therefore they're equal. Even if I was to do that, you see that? So just mind my drawings. So this was chord AB, and this angle will also be 46. Again, same if I had to go other way around, it will also be 46. Angles in the same segments are equal. Also have a look at that particular question. This question here, obviously part C, now it deals with what we call a cyclic quadrilateral. It's a quadrilateral that touches a circle at 4 places, all right, the circumference. And what is interesting is that the angles that are opposite each other, like the whole angle x minus 21 degrees and x plus 15 degrees, they are all going to be adding up to 180 degrees. And once I use that fact, I can solve to find the value of x. Another very interesting one is that the exterior angle of a cyclic quadrilateral, like the whole one here, is always equal to the opposite interior angle. So that is why I'm equating them there. I solve for x, and that's how I know that that answer is equal to 90 degrees. Question 10, well, here, this one is also in your textbook. Please have a look. Interior angle of an equilateral triangle. You should know equilateral triangle. I've got 3 equal sides, 3 equal angles. Each angle is 60 degrees. Interior angle of an octagon using the formula. I know I'll get this one. 24-sided using the formula again. I get 165. Now, if I add all of them and they give me 360, it means that all of them will fit on top of each other. Not on top, but they will fit next to each other. So that is the test that I gave you on I think the 18th or so of April, and you had to look through it. Some of us did it, some of us did not. I gave you work today where I said you were supposed to do some few things. Now the first week of June, I expect the government to give us an idea as to what is it that we actually had to do. So if school opens on the 3rd of June, all right, for grade 11 and 12, you will realize that I'm going to test you again on this very same topic, and I expect you to do much better. And there's going to be a lot of work, and I'm proposing quite a few things that I have to talk with my colleagues based on all the work that we have to finish. All right, this is Mr. Max signing out. Goodbye.